Hello everyone, we are from Group 6. We'd like to present our presentation. So for introduction, my name is EUGENE GHANI, ANAK Jacob. My metric number is 208563. So for introduction of trust is defined by Francis Bacon as a frame structure consisting of a triangle or a group of triangles arranged in such a way that only tension and compression in the member will be caused by a load applied at the intersection point of a member. The engineering concept behind the truss is the shape of a triangle or triangle series. In architecture and structural engineering, a truss is a structure comprising one or more triangular units constructed with a straight member whose ends are not connected at the joint referred to as knot. External forces and the reaction to the force is considered only at the knot, and result is a force in the member which are either tensile or compressive force. So for introduction of frame is a frame a rigid structure. They maintain their shape with or without external load. The forces acting at the joint and support can be determined by applying the equation of equilibrium to each of its members. Once these forces are obtained, it is then possible to design the size of the member, connection, and support using the theory mechanics of material and appropriate engineering design code. So for machine, is a machine a non-rigid structure which contain one or more multi-force member. A multi-force member is one who acting on it three or more forces, or two or more forces, and one or more couple. Machines are structured designed to convey forces and modify them. The primary objective is to turn input and into output forces. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is FARHAN FAIZEEN ROZAIMI YAZI. My matrix number is 206481. So today I'll present about trusses. For the real structure, we have located in English Landing Park, Parkville, United States. So assumption that we can make is the first one: trusses consist of all straight members connected together with pin joints or nodes. The second one is all forces are in equilibrium state. And the third one is the total of moment is zero. The total of vertical and horizontal force is also zero because it remains static. Okay, the last one is the external force are applied only at the joints. So here's a picture of the real structure. It is a horse trusses at English Landing Park, Parkville. Okay, so here's a free body diagram of the structure. As we can see, the external force only acting at the end of the joint. Okay, so reaction and external loads on the structure. So for joint A, we can see there are two reactions. The first one is vertical forces and horizontal forces. While for joint E, we can see there are only one reaction. It is a vertical force only. For external loads, we can see there are three external loads acting on each end of joint B, C, and D. So here's an example of calculation to find the force of BC members. So so we can see these BC members. So this example to calculate the force. As we can see, we will get negative. So negative means it's a compression. So then if we calculate all the joints, for example, we calculate the B, C, and D joints, we'll get which member are in tension and compression. Okay, so the conclusion. The truss is a building invention that allows for better support to distribute the weight of a roof to the outer walls. Truss provides more assistance and allow builders to use fewer materials for any construction to be achieved. It's also a distribution of load. It also has a higher maintenance demand of all joints and fitting more calculation to determine that it will take the maximum load. So there are two process to determine the member force. There are joint method and section method. So these two method can use to determine the force of each members. Okay, by that, in each member and each joint, we conclude force. So trust play a vital role in our surrounding. For example, everywhere like in the bridge, as we shown in the picture, building and rooftop. That's all from me. Thank you.
Assalamualaikum and a good day to our lecturer, Dr. Noorfaizal Yidris, and also to my fellow classmates. My name is Zainul Ariffin bin Muhammad Idris from Group 6 with metric number 208428. And today I will present to you guys about the analysis of frame structure that we have chosen. So this is the picture of the frame structure which is located at one of the building at SMK Sultan Yusuf. And notice that each of the joints of the structure have been labeled as A, B, C, D, and E. And based on the structure, we have developed a few assumptions, which is members ACE and ABD are connected by the pin at A, and members BE and ABD are connected by pin at B. Member BC is a link, and we assume that link BC is in tension and exerts equal and opposite force at B and C. Other than that, the structure is in equilibrium condition, and we assume that there have a load act on the member ACE in y-axis. Lastly, we assume that the deformation of the structure, which caused by the loads, are small and does not change the original design of the structure. So based on the assumption that we have developed, here is the free body diagram for the whole structure. And as I have mentioned before, there have loads of 2 kN and 3 kN act in the middle of AC and CE. And by applying the equilibrium equation and calculate the moment at E and D, we will be able to calculate the value of dx and ex. So we move to the reaction and external load of the structure. This is the free body diagram for the member BE, and we have to note that BE is a two-force member, which is mean the reaction at E must be directed along BE. By that, we can use the length of BE in X and Y direction to determine the value of EY, and by substitute value of EY into the equation of equilibrium for Y direction for the whole structure, we will be able to determine the value of dy, which is equal to 2750 Newton. So this is a free body diagram for member ACE. By calculating the moment at A, we'll be able to determine the force at BC, which is equal to 1000 Newton. And by applying the equilibrium equation for Y direction, we will be able to determine the value of AY, which is equal to 3750 Newton. So next is the free body diagram for the member ABD. So we have to note that force at BC will be equal to force at BE to the ratio of 0.9 over 1.7. By that, we will get force at BE will be equal to 1888 Newton. Okay, so next is the free body diagram for member BC, and which is, as I have mentioned earlier, we assume that the link BE is in the tension and it will exert equal and opposite force at B and C. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD bin ARMAN. My matrix number is 209087, and today I would like to present static machines. So this is the table of content. For the introduction and conclusion parts, my friends Eugene already presented, so the other part I will present. For the first part is assumption. There are 4 assumptions that we need Okay, the first one is we assume that the internal forces at the center A are both in positive value of x and y axis. Second, all forces in equilibrium. And third, total moment is equal to 0. Total force in y-axis and x-axis is also equal to 0. And fourth, the external force are applied at the end of the plier. Okay, this is the picture of the structure. The free body diagram. Okay, this is the reaction and external force. As we said that this at center A, we assume that the reaction is in both positive direction, positive x direction and positive y direction for the part A. And for the part B, we assume that the center at A must be in different direction than the first part E. Okay, this is the calculation. Okay, that's it from me. Thank you.
So for conclusion, the truss is a building invention that allows for better support to distribute the weight of a roof to the outer wall. Truss provide more assistance and allow builder to use fewer material to any construction to be achieved. It allows distribution of load. Trusses play a vital role in our surrounding, for example, everywhere in like in a bridge, building and rooftop. Machines are structured with transport input forces and moment to output forces and moment, and generally involve moving part. There are a lot of frame structure can be seen in our daily life. We manage to make assumption of a structure where deformation of a structure which causes by load of are small and does not change the original design of the structure. That's all from me. Thank you.